here in Valencia. So, to start this second day of the conference, I think it's not better manner to start than having a refreshing keynote speech. And for me, it's a real pleasure and an honor to introduce you, Professor Keynote. I remember meeting him in 2001 at Georgia Tech, when he was a very young professor, but already a pioneer in the area of mobile ad hoc network. And let me just cite you, just in case you don't know, Professor talks some of his endless merits. Professor Top pioneered the field of mobile ad hoc network and wrote the first book in this area in 2000, and it became Apprentice Hall Engineering title bestseller. In the academia, he has been at Georgia Tech. He was also at UK, at London University, and as well as National Tsinghua University. But he was not only in academia, he was also in industry. He joined the TRW system and an ecosystem in the States, and he also acted and served as CTO of Infocom Development Authority of Singapore. Of course, he has been serving for IEEE and IEEE ComSoc in many leading activities. I don't know if you know, but Professor Tok was the founder of the MobiHawk conference time ago. He was the founder. He has some merits, just to cite you some of them. He has the FREng medal in 2009. He also has the Kyoto Misayum medal in 2005. He's fellow of many different associations. He's fellow of IEEE since 2009, fellow of the American Association for the Advancement of Science also since 2009, and fellow of the British Computer Society since 2003. So please join me to welcome Professor Tok with a big applause. So, Professor Tok, you have the floor.
Okay, thank you, Juan Carlos, for the very nice introduction. I'm really glad to be back here in Valencia. I remember coming here maybe in the early 2000s, and Juan Carlos convinced me to come to Spain and make a visit and have a look at the exciting research that the UPV team are trying to do, which I left pretty impressed. Okay, so I'd like to thank the organizers today for inviting me here. Okay, my name is Keynote, and it's my pleasure to be here today. My keynote is going to be the title, The Rise of Smart Cities. Okay. I've actually written a script because I felt I wanted to have all the details for you today, right? So that you don't go away empty-handed. Okay, let's move on. So my talk will have 6 parts. First part, I will have the introduction on the topic and a little bit about myself. And then I'll talk about the evolution of smart cities. Okay? And then we'll go deeper to talk about the fundamentals, which I will discuss standards, architecture, technologies, and applications. And then followed by part 5, challenges in the future. And then part 6, the conclusion. Okay? So part 1, introduction. I'll talk a little bit how far we have been, right? So 23 years have passed. So I remember I graduated in 1996, and now it's already 2019. Everybody expects me to be an old man, okay, which I am actually. So 2 decades have passed, time flies. I'm still back here in Valencia. Thank you all, good friends. So my first 2 papers were published in IC3N in the year 2000. Right? Some of you may not have attended the IC3N 2000, but I was there. I published 2 papers. So over the past 2 decades, I've been through both university and industries. So compared to some of you which hasn't really embarked your journey on industry, I welcome you to do so. Because right now, if you were to keep staying in academia, you only have one perspective. Okay? I'm not saying that's not good, but I'm saying it's always good to have greater contribution and greater exposure. Okay, next, a little bit more. After this slide, I'm not going to talk about it. Okay, so as Juan has introduced, I created MobiHawk together with Charlie Perkins. I'm sure you may have heard about him. But then eventually I left MobiHawk. I also left ACM and InfoCom as well. I don't go to conferences very much these days. Okay, and then I got a couple of awards for my previous work. And then eventually I moved to industries. I still have interest with universities, very much because university give you that academic research freedom. Okay? But I do like industry as well because industry give you that down-to-earth feel that you're able to deploy your creation to be used by millions or billions of people. Okay? So on the right, I talk about what hasn't been changed. It's my passion for technology, my care about research ethics and integrity. Okay, now, I don't really like people, to have academic bully, conspiracy, or corruption. I don't support that at all, and I emphasize a lot on research impact. And I don't listen to rumors. I actually prefer to know you in person. Okay, if somebody tells me about the bad things about you, I don't care that. I actually care only if I know you. If I don't know you, I can't comment. That's just my style. Okay? All right, let's go deeper about my research. So from A to man, right? So I started off as a PhD student in the 1990s, working on ad hoc networks. And at that time, it's kind of like myth or hype, right? So when you do a research, you wanted to explore something that's totally unknown and new. And hopefully you can create impact. You can create new knowledge. So at that time, having networks that constantly move around, right? The connectivity is the challenge, which is why routing comes into the picture, right? And then in the early days, it was Wi-Fi. So you have Ethernet over Wi-Fi, and then you want to create ad hoc over it. So you have Wi-Fi ad hoc. And then people wanted to change CSMA, CA, or CD, right? To enable the MAC so that you have less collision and you have more data packets going through. So the innovations were done on routing, media access control, and then people move higher up end-to-end to deal with ad hoc TCP connections, right? So how do you have TCP data transmission from source to destination when you have intermediate nodes that move around? How do you resolve that route reconfiguration and enable data transfer despite mobility? And then you have the standards that come in, ZigBee and Z-Wave, and people explore ad hoc multicast, right? People explore discovery of other nodes and their associated services. And then we move on, right? So you can see from 93 until 2000 to 2010, and very soon we're coming to 2020, right? So this shows you that spectrum of 20 over years or more. Okay, so some people say this area of ad hoc networks have actually purged. I don't think so. I think it has taken different forms. So for example, you look at VARNets, right? So a lot of research activity now on VARNets, vehicular ad hoc networks. People are talking about V2X, even UAV networks. And then eventually the applications of ad hoc sensor networks into smart homes, smart transport, and now smart cities, right? Which is why I'm talking about smart cities today, right? I'm looking towards the right-hand side of the spectrum. Okay, I believe we have another 5 to 10 more years to go in that side of the spectrum. Okay, so if you are working on ad hoc networks, you're interested on its direction, you can follow me, or you can find your direction. Okay. Okay, next. So people will come and ask me, since you have worked on ad hoc networks for 20 over years, so what's next after mobile ad hoc networks? Okay. So that will be the next wave. What will be the next wave? Is it future internet? Is it artificial intelligence? Is it quantum computing? Is it bio-inspired networks? Or is it blockchain everything? Because blockchain now is so popular. Everybody is talking about blockchain. You use it for anything, all right? Now the interesting is why you want to know what is coming. Right? We all know tsunami of everything. If you are not prepared, you get overwhelmed, you get wiped out. You're doing something insignificant in your research. Nobody cares what you do because it doesn't create much impact. That's why people want to know what is the next wave. Not just influencing academics, but also influencing industry or globally as a whole. Right? So as a researcher, it's not so much about the tiny little details that you're doing. Because if you're going to spend a lifetime, 10 years or 20 years or more, you wanted your research to create substantial impact. Okay? So the interesting about this figure is this guy, I don't have a pointer, but there's a small little guy in front of the wave. Did you see that guy? Can you see him? I'm not sure I can get the pointer. Yeah, I can't get, oh, here you go. So there's this little guy here. All right, so he's standing in front of the huge tsunami, and he's not afraid. So probably because he doesn't know what is coming. If he knows what is coming, he should be 10 miles away from the wave, okay, up on the higher ground. Okay, so I felt, this is a good picture to inspire you to think what is ahead, what is coming that is matter to a lot of us. Okay? So anybody knows the answer? So it could be one of those. So my thinking was, after giving it some thought, I felt to me the next big wave is smart cities. Okay, so are we moving towards a civilization similar to the lost city of Atlantis? Some of you may have read the story about Atlantis, and I think Plato talked about it. Plato is the great philosopher. Yeah? So I'm sure some of you know him. So he mentioned about the lost city of Atlantis in his notebook somewhere. And this is a city of very intelligent people. Okay, now think about it. Smart cities. Why are we driving the whole world of civilization towards smart cities? Right? It means we're getting smarter, right? In our infrastructure, in the way we live, in our technology, so on and so forth. So we are trying to create Atlantis on Earth. Again, okay? So if you don't believe, let's go deeper, and we'll find out more if this is true. Okay, I have a quote from John Chofi from Stanford. He talked about the flying cars, right? He says, flying cars, it's coming for sure. Okay, and I put there 2050 for the flying cars. It's coming to the globe. Okay, and we are going to have this sort of transport. So basically, one cannot deny progress, right, and evolution. Okay, that's how it is, the way we live our lives. Okay, so resistance to progress is Buddha. If you remember the Star Wars movie. All right, so we have to embrace progress. So some of you will ask me this question again. So what is a smart city? Right, so before we even talk about Atlantis, let's re-examine realistically what is a smart city. Okay, so let's start with part 2, evolution. How does the smart city comes about? Who created this idea of smart city? And what should we do the research on it? Okay? Well, really, there are really prime motivation factors. Okay? there are world-pressing issues that is affecting each one of us here, right? The issues about these troubles: pollution, floods, hunger, earthquakes, energy crisis, physical divide, congestion, traffic accidents and death, terminal disease and deaths. Right? So after so many years, human civilization is still affected by all these factors. All these factors are not fully solved. Right? Since the days of Newton until now, these problems are not solved. So how many generations of talent has gone and all these problems are not solved? Right? Okay, so these are very critical problems that we hope one day we will overcome, we will conquer. So that forms the motivation for smart cities. Right, so the evolution is actually, we are migrating to a new world, right? And in this new world, as Huawei said it, it's all things connected, all things sensing, and all things intelligent. Okay, so the ICT infrastructure will be the foundation for the whole new intelligent world. So we're trying to build an intelligent world. Okay, so you can see the arrival of the sensing, the connectivity, and the intelligence. Okay, so the evolution started off a while back. Maybe we don't realize it when we were trying to explore digital city. So you may have heard about digital cities, right? In the late 90s and early 2000s. And then eventually we start to move and focus on intelligent city, right? I think the Japanese people was looking at that, intelligent city. And then eventually now, at our decade, we are looking at smart city. Okay, so if you reflect the old days, actually we evolved. Okay, starting off from digital cities. In some governments, some countries actually work on that. Cool. So there's a certain level of evolution. Now, some of you may even know more, right? So we can take a look at this, that some of you may remember digital cities, safe cities, ubiquitous cities, green cities, sustainable cities, connected cities, right? You probably are familiar with all these terms. So how important is smart city? Is it a big deal, right? Well, let me explain why it's a big deal. So according to Frost and Sullivan, so one of the research company, global smart cities market will exceed 2 trillion by 2025, right? And almost the smart city projects will amount to 320 billion for China, right? And China will have more than 50% of the smart cities developments in Asia by 2025. So we're talking matter of scale in the form of trillions and billions. And that's no small matter, right? So it's really, really important. So let's face it, right? The world is moving towards smart cities. You may not, but you live in this world. Right? Until you have your own shuttle, you fly up overseas into space, that's another story. But as long as you are in this world, the world is moving towards smart cities. These are the countries driving it. China, right? India, USA, UK, Europe, Singapore, and so forth. In fact, China and India are the two largest smart cities development in their country. They are pushing it very hard, right? China alone has over 300 projects, and India has over 100 smart city projects. Okay. So some of you may have already been participating. I know that IBM has played some of those early roles. So are other companies as well. Now for China, these are some of the cities that have smart city development in Wuxi, Jiangsu in China, in Sichuan, in Ningxia, China, in Hangzhou, the hometown of the Alibaba. Okay, so they have a lot of smart city projects in their cities. Okay. In Japan as well. In Japan, you have the Fujisawa Smart Sustainable Town. Okay, so it's Yokohama, Keihana, and Kitakusu. Okay. Same thing here. If you look at Japan, they are interested in ubiquitous city in the past, now moving on into green, sustainable, and efficient cities. So this green thing, it's still part of smart city. Okay, so you want to have a city that is not generating too much waste and not consuming too much resources. Okay, so Japanese are really interested in that. Okay, so even for Korea, right? So Sejong and Busan, they have projects on that too. Okay, I'm not going to go into the detail, but some of the smart city projects actually improve transportation, improve their life, their health and safety, and even have better administration. Okay, so if you're interested, you can Google and search for these two cities and find out what they have done for their district. Okay, so smart city is real. We have seen China, we have seen Japan and Korea and their projects ongoing with it. But the development of smart cities has to go through transition, right? You have to start off from the beginning and you go to intermediate, and then eventually you'll be a leader as a smart city developing country, right? So for any new country or any new city that wanted to start smart city development, they had to start from the beginning. Okay, so if you have an empty stretch of land, you can start planning. You have an existing city, you may want to renovate, retrofit, and so forth. Okay? So according to ESI, a lot of cities, right, are doing smart city. The one on the right-hand side are the leaders. I showed here Boston, Chicago, Copenhagen, San Francisco, and so forth. So those are considered the leaders in smart city projects. The one on the left-hand side, these are the beginners. Okay, so there are a lot of cities here. So it's impossible for me to go through every one of them. Okay, so with everyone doing smart cities, how do we rank them? How do we measure how well they are doing? So there's something called Smart City Index. Okay, those who like to do measurements and analysis, this is one good index. So by Juniper Research, these are the top 5 cities ranked recently. Okay, on the right-hand side, it's the ranking done by IESE. New York, London, and Paris emerge as the top 3. Okay, so they look at how smart is smart, right? When they created this city, how smart is smart, and how does that improve the lives of the city residents? So a couple of parameters. Right? So if you are doing research in this aspect, you may want to drill down into the parameters, okay, so that you get real. Whether the city actually is more efficient, more green, people are more happy, so on and so forth. Okay, so you have understood now. Smart city is very broad, but it seems to be quite real because there are countries out there that are doing smart cities. Let's go deeper into the fundamentals. Okay, so I come back to you again. What is a smart city? Right? I haven't quite answered this question. Some of you may think that pyramid structure there is a smart city. It looks really fancy and futuristic. Okay, let's move on. According to ITU, right, a smart city is an innovative city that uses ICT, info communication technology to improve quality of lives, efficiency of urban operations, competitiveness, meeting the needs of present and future generations, generation means human, economically, socially, and environmentally. Okay, that's the formal definition of a smart city according to ITU. Okay, so there are other definitions, but I've cited ITU here. So the use of technology to improve the life of people. Okay, sounds really good, right? Because we all live in the city, or we all live in Earth, and we wanted our life to be better. Even better if it's for future generations as well. And the new city should come with these characteristics, right? So safety, efficiency, sustainability, green, superiority, advanced interoperability, better quality of life. So you can need a lot more of these characteristics. So when you design a city, you need to know the feature. What is it that you wanted to introduce into the smart city? Okay, so once you know the feature, you can use the tech to produce and fulfill that feature. Okay? So, with all this sounds good. What about focus? Right, so let's zoom a little bit higher up. So if you are the governor, the city mayor, you want to create a smart city, what is your focus? Should it be your citizens, citizen-centric, or should it be about services? What kind of services you want to give to your citizens in your city? Okay? Or should it be future-proof? That means this city is going to have this new transformation that will last 10 decades, 100 years or more. Okay, so the city mayor has to come up with that focus, that vision. Okay, so, but we need to go a little bit more deeper. A smart city also needs to fulfill some kind of services, right? So within the city, you know, you will have some kind of transport. It helps you to get from point A to point B. Okay, this is like indispensable. You need it. Otherwise, you're stuck. Right? Otherwise, I can't be here today. Right? The other one is health. Right? So each one of us need to have some kind of health service provided by the city. Right? It could be hospital, it could be clinics, family doctors, and so forth. And also housing, right? Smart living. Where will you live? You can't live in a hotel. They will charge you 200 euros a day. So you need to live somewhere that is affordable, right? You can establish your family. Okay, you can settle your roots and do your thing. So I coined this atomic structure of a smart city. The essential elements that make up a smart city, where the city's residents like yourself will need, because each one of us will need this sort of thing. Right? So when you leave, you need to consume, you need to have water, you need to have utility, so on and so forth. Right? You need this, otherwise your life is hard. Okay, so now if you think along that line and go even more deeper, you can think a little bit like a constellation. So if smart cities is the star of the galaxy, this constellation, okay, then the rest, things like retail, transport, governance, people, health, living, education, safety, forms the constellation around smart cities. Okay, something that you will all need to make your life better. So let's come back to planet Earth. Let's go to Shenzhen in China. The city of Shenzhen actually looks at smart city in terms of 3 layers. So pardon me for the Chinese, because I just take it straight from their report. So smart city in Shenzhen, the architectural view is actually 3 layers, right? So the bottom layer talks about sensing and connectivity. The middle layer talks about the data platform. Okay. And then the third upper layer talk about the applications and services. Okay, so that's how Shenzhen. Have you been to Shenzhen? No? Okay, some of you have been there. It's actually quite a very modern city. I'm quite impressed. It's doing very, very well. It's the headquarters of Tencent as well. So that's how they do it. So you might think, interesting, architecture. I can do a research in architecture. Go ahead. I think we need more brains in this aspect. Okay, so I've taken a real life example. Shenzhen City is viewing it this way. Okay, so I extract another architecture. So I say a new architecture for smart city, how the industry look at it, right? So I show you here Huawei, Siemens, and the rest. So essentially, you can think of smart city as 3 to 4 layers, right? So we always need the bottom layer for the sensing and the infrastructure and the connectivity. We need the middle layer to generate, process the data, and even generate intelligence and insight. Okay, and we will definitely need the upper layers to provide the application and services to the citizens, to the residents of the smart cities, right? So if you think of it, well, this is quite different from the internet, right? Okay, so this is like a system of system. This is a big project, okay? Because it impacts things, it impacts humans. It has impacts machine, it uses cloud, it has data. Okay? All right, so now we have learned a bit, right? So it seems to be vague, but now you see the architecture. How about we go a little bit more? It's important such that standardization bodies are looking at it, right? So bodies like BSI, the British Standards Institute, the ITUT, T for telecom, the IEC, and the IEEE. And even the standards, they cover technical, process, and strategy. Now remember, smart cities are led by government leaders, right, who actually have millions and billions of dollars of budget. And they will, engage committee, they will engage contractors, they will have a blueprint or a roadmap, and then they will run this project. So it's not just the process. How are you going to kick off this process when you run a multi-billion-dollar project? So that you don't mess it up, right? And what's your strategy? Okay, so as you address a big project, it's very different from a university research lab project. Okay, so that's why we have process standards and strategy standards. So coming back to the architecture again. So ITUT SSU has this 2015 architecture that more or less resembles Shenzhen and the others, right? Sensing layer, communication layer, the data layer, and the applications. Okay, so they are not too far away. You can add 1 or 2 layers, but something you will realize is the vertical layer, right? On the right-hand side. You see the security system, SSC, cutting across all layers. So they're trying to build secure smart cities. Right? So security, to me, security is vertically across the horizontal layers. So is your management as well. Okay. So quickly, BSI, I really like it. BSI have a very different perspective. Look at technical specification, process, and strategy. Okay, so if you're a project manager, you will love this because it tells you more than just all the technical details. So some of these are available on their website, so feel free to read through this. It will help and enhance your understanding. Okay, IEEE comes in too. IEEE is very interested in smart city. So I myself is a member of the IEEE Smart City Initiative, which brings together different societies. Okay, So IEEE says, good, smart city, I will introduce some of our IoT standards. Okay, I'll incorporate some of our ITS standards, incorporate some of our Wi-Fi standards for the smart home, and so forth. So IEEE is also coming in. Okay, but primarily on the technical aspects, not so much on the process or the strategy. Okay, so remember the term roadmaps, because if you were to become a leader of a smart city project for the whole city or for your country, you need to define a roadmap. So we lay out the essentials and how to get there. Okay, so you can go through each of these countries, China, Japan, Hong Kong, Singapore. You'll find their roadmaps and their blueprint. So feel free to read through it because it's quite big. It's impossible for me to, digest everything and say it here, but please do read it. Then you can understand the minds of the leaders as they try to develop their cities. Okay, so standards is one thing. Let's go back a little bit deeper again. What essentially is running the smart city? What is it trying to do? What this engine is trying to do? It's basically to sense something, right? So there is a sensing element, there is a connect element, there's a data element. The data is you are going to generate data, right? You're going to transport the data from one place to the other. And you're going to process that data, analyze, and create intelligence. Using that intelligence, you're going to drive your applications. That's the essential of it. It has to perform this 5 or more functions, regardless of whatever technology you use. Okay? So that's how I do it. You need to have these 5 functions, whether it's a smart city in Dubai or a smart city in Bali. Okay, so functions are good. Let's go deeper. What are the key technologies driving this to achieve this? Well, I mentioned you need data, right? So you have data fusion, data analytics. You have all sort of wireless connectivity. You need to have artificial intelligence. You need to have security. You need to have sensors and Internet of Things. And you need geospatial. And geospatial comes from geoscience. And you have a community from geography. Right? I'm not saying something like this. I want to make it clear. Smart city is a multidisciplinary topic. Okay, make it clear now. You have urban science, you have geoscience, you have computer science, you have electrical engineering science, and so forth, right? So smart city is a fusion of multi-disciplines. So you need geospatial and GIS as well. Okay, so all these need to come together and create a good chemistry. So I mentioned here a new city powered by multidisciplinary technologies. So I highlighted the AI because especially in these few years, AI plays such a major role, okay, for smart cities and others. So one of you may be working in one or more of these areas, right? And I believe that we are getting more and more diversified. Okay, if you just work on signals, maybe it's not good enough. You need to have more than one skill. So what are all these driving at, right? Well, I think we are trying to create something very interesting here. We're trying to create a city brain. Okay, have you digested this? Right, so with all these functions and all this fusion of technologies, with all this sensing out there, and the AI, we're trying to create a city brain. Okay, so that this brain itself is autonomous because it can find out are the city residents have a good living condition? Is the city safe overall? Right? Is the water clean and safe to drink? Are the people in the city healthy? Is the air quality in the city okay? And so forth. So this is very interesting. Right? So before, in the past, a city, who runs it? The city mayor's office. Right? And those are essentially administrators. Right? But now think about the transformation, the arrival of the city brain. And the city brain can do all these checks for you, right? And make things better. So I think this itself is really a transformation that we don't have in the past, right? So you go and talk to the city mayor saying, I want to create a city brain. And he will just look at you totally blank. And heaven have no clue how you're going to do it and what is he trying to do. Right, so Huawei actually tried to make a city brain. Right? So it's something called IOC, Intelligent Operation Center. So the IOC is like the master brain. It has the eyes, the ears, the hands, and mechanisms. So it will monitor what's going on within the city. Okay? So with sensors and IoT around in the city will get more intelligent, right? So IoC acts as like a human managing the central nervous system for smart cities. So you can have a big screen, you can look at what's the air quality right now within the city, you can look at the congestion situation within the city, people flow, which area are more congested than the others, and so forth. Okay? Okay, so now we understood there is a city brain. We understood the various key sensing functions. We also understood the key technologies behind it. What about the applications? I still have 15 minutes. So what are you interested in terms of city services that will benefit you, right? So is it about efficient transport? I can get from point A to point B in 1 minute. Or is it about whenever I'm sick, I will never get sick? Okay? Or is it about my living, that my living is so superb that I can live until I'm age 200? Okay? Different people, different aspect matters to them more. Okay? So, but this comes with smart city, right? So I show you here a diagram on the right. Actually, this is a little bit of an imaginary down ahead, that when you stare at the mirror tells you how healthy you are. I think this is really good, right? If there's such a thing. Because every morning when you wake up, you stare at the mirror, you brush your teeth, right? And then as you do that, the mirror try to understand how healthy you are today. If we have that type, this is exciting. Okay, so I'm going to cover about transport, health, and living before closing this up. First thing, smart living. Now, humans generate a lot of waste. So you can do research in smart waste management. Right? So in the city, people throw rubbish and so forth. So we were trying to reduce wastage. We wanted to have recycling. Right? But even recycling itself is a challenge. Because some people don't do it. Sometimes we don't know how to get rid of the rubbish. So we send them back. Recently, some countries send their rubbish back to the country of origin. This is interesting. But I think in the smart city of the future, the waste management can even go deeper to underground, right? Where some of the trash get processed and channeled through underground pipes. Okay, so that all the smell, odor, and so forth doesn't really comes above ground. Okay, it's all hidden. You don't see the trash. You don't see the rubbish. Okay? So this is a kind of vision where the buildings that you are in or the retail and so forth, their rubbish are actually handled underground. Okay? And I think this is really exciting because this is a different way of constructing city. Next aspect of smart living is about public safety. So if you want to live in safe neighborhoods, that is most desirable, right? You don't want to live in a place where you get robbed or you get killed. So public safety is a key concern. If we can create a safe environment, people would like to live there, right? So the smart city brain can actually tell you, okay, which area has crimes to avoid, or which area when the crime is happening, you call the police and you resolve the crime. Okay, so we are transforming the public safety and enabling it using technology. And also trying to catch the bad guys, right? So public safety, we can use vision, computer vision, we can use facial recognition, we can use tagging, and so forth. We can identify individuals, and then we can actually locate them and even make the arrest if needed. Right? So this everything gets very efficient. Obviously, some of you may say, Big Brother is watching me. I'm sure when you get out, you see cameras, some of them on the street already. Right? So I think in the future, there are certain aspects we need to compromise to enjoy living in this hazard-free, crime-free environment. We need the help of technology to come in. Okay. You can also have iris recognition, but iris recognition requires really high resolution zooming into the individual. Okay, not just the fractal recognition. Okay, smart health. Now, if you go to China, you will know the pollution situation is quite bad. And so I think smart health will be top priority for China. Okay? So, but how do we deal with that using IoT sensors and all that? How do we improve air quality? You can't deploy, 1 million so-called air cleaners machine on the street. Okay, China has been trying to use so-called artificial rain to flush out pollutants from the air. Okay, now when you deal with a huge space that is polluted, how do we solve it? Right, sensors only measure, but they do not remove the pollutant. How do you remove pollutants on a large scale? Right, this is the $1 million question. Okay, so I think that's where research needs to come in. That we can actually transform the air within the city from really something very high PSI, really bad, dangerous air quality to something that's decent for you to breathe. That's the challenge. That's the big challenge. Okay, that affects your health. The other thing with AI and data analytics, right? We have predictive healthcare. So as the name implies, I collect data from your body and from your surrounding. I can predict, are you likely to fall ill? Are you likely to have some kind of a seizure? Are you going to have a panting heart attack? Or you have a blood clot and you may have a stroke? Right? So we are doing something advanced. We're predicting your health situation. Right? Not going to see the doctor until when you're sick. That's not enough. That's already sick. That's why you go and see the doctor. But now I'm saying that you may get sick within the next 5 hours. Let me do something. Right? So predictive healthcare is enabled and it's under smart health. So if you are able to do predictive healthcare, you have achieved preventive healthcare. Because I prevented you from falling sick. Right? So in some of this preventive healthcare, not just data, but you actually use implantables, right? So you use the sensors that you may swallow, that monitor your body condition, right? And update that predictive analytics going on your health. Okay, so you can see that they are intertwined, right? Predictive and preventive healthcare. These are something that will be as part of smart health. Okay? Not the time when you are sick, then you go and see a doctor. Better still is don't need to see a doctor so frequently. Okay? So it's going to transform medicine for sure. Right? You will make people more healthier and live longer. Okay, smart transport. I mentioned that with the city brain, you are able to monitor congestion, and then you are able to reroute traffic. Your life is going to be better. To get from point A to point B, right? You will know the current situation as you drive, and then you are able to take the right route to your destination. Now, this has been implemented by Alibaba. They have sold it to some governments. In fact, Malaysia has a project with Alibaba. Okay? And they are doing this city brain for their smart traffic management system. Okay? So you can look up more about this. But smart transport is not just about this whole big system. It's about 1, 2, 3. You may have heard about Airbus, which divide a flying car into 3 modules. One is the ground module, the other one is the passenger capsule, and the third one is the air module. So if you combine 1, 2, 3, you have a flying car. So that's why I coined a new term, vehicle to air, or vehicle to space or to sky, okay, V2S or V2A. With that 3 combo, you have a flying car. It will get you somewhere. So as you know, transport is multimodal. You may take a bus, you may take a flying car, you may take a bullet train before you can reach into it. Right? So we will still need different types of transport mechanism. Okay? And even recently, the exciting part, you probably heard about this. Have you heard about it? Yeah? So Richard versus Frankie. Okay, Richard Bounding from UK actually created this flying suit propelled by jet turbines, mini jet turbines wearing on his suit, and he can actually fly. So FREng Zapata actually created a flying hoverboard. He actually flies. Okay, so these are real technology, really working. They are not for purchase. But think about it, we have flying car and we have flying man. Okay, now, flying man doesn't get you from Spain to China. That's too far. Maybe not anymore. But what I'm trying to say is that this is one form of smart transport. This may get you from, say, Valencia to a nearby city. Okay? So I think we already see all this evolving. Okay, so I'm going to finish up. Right? Only have a few more slides. The challenges and the future. So what are the challenges? You may think, wow, this is a big problem space. This is multidisciplinary. You're right. There's a large scale of systems of systems. But where to start? This is a good question. Where for you to start? Okay? What to do in the research? Right? What about citizens? Whatever you do you think the citizens will like it? They will actually want to use your tech, your creation? And what about security? So smart cities come with a lot of challenges. Okay? So it's not a one-person show. It does require quite a community of efforts. So I mentioned the various key players here: government, industry, standards bodies, and universities. But I think the university research is kind of lagging behind, primarily because academics require funding before they do the research. So they need to write a proposal, they need to get that funded before they can actually do research. But I think industry and government are really pushing it ahead already, right? So in this aspect, I think universities are behind. Never mind, but I think it's time that the professors get to know about it and start doing the research. So finishing up the future. What about the future, right? About smart cities. Is it an elevated city that's shown here? Right? Smart cities will not stop evolving. As I say, progress you cannot deny. People have been thinking about future cities, mega city, cluster cities. So what will future cities look like when we run out of land? Will we have elevated cities? I don't know. So I want you to imagine maybe beyond your lifetime. Okay? Dare to imagine that. What about floatable cities? Especially now it's so warm. Right? Imagine in the future we are at 50 degrees Celsius. Can we still survive living above ground? Or do we need to live half submerged, half on the ground? Possible, right? So we have floatable cities, right? And you can see from here, you can still grow something above the ground, and underneath the sea, obviously the temperature is cooler. You can enjoy marine life, right? You can even harvest seafood, okay, and so forth. So imagine how that would transform your life, okay, as we combat global warming. I told you already, after so many decades, we haven't solved some of the world pressing issues, right? So world pressing issues are not solved yet. Maybe the way we live, it's not so good, not so right, okay? What else? Sky City. If we're so good in our engine that we can propel, can we propel the whole city above the ground? And why do we need to live at 10,000 feet? Same question as why should planes fly at 10,000 feet? Okay, anyway, I'll leave it to you to go and think. Okay, as you can fly, your city can move. As you move, maybe your environment will be better. Yeah? So I don't want to restrict your imagination. How your future generation, your granddaughters, and so forth will live as the world transforms into a harsh environment. Okay? And finally, let me close up. Think about future smart city as cognitive cities. Right? So I talk about this city brain. The cities that continues to be smart, able to survive, and provide the best for the residents. So it's a cognitive city. It understands its situation, it understands what needs to be improved, what needs to be done. So AI will have a much bigger role here. And AI at a larger scale, very large scale. You may need a supercomputer. Okay, so I think that's the really fancy part of smart city. So let me conclude because I finished 1 hour. After all this, how are you going to design and build your smart city? Okay? Because we live in different parts of the globe. We have different thinking. You might want to preserve your culture. Right? You still want your culture. You still want your language. Right? You still want your music. You don't want your city to ruin everything. So you still need to preserve some aspects of that. So let me finish up. So I think we are building a whole brand new world. Okay? A smart cities that will have smart people. Okay? Because we're trying to solve really big issues. A smart community, smart transport, mobility, health, living, and so forth. So I think we need to get ready for the arrival of the new Atlantis. Okay? Okay, so that's the end of my talk. Thank you.
Thank you so much, Professor. I think that we have time for 1 or 2 short questions. Any questions?
Okay, anyone brave enough think about the future and ask? And I think I think with Atlantis putting on board, I want you to really be able to think ahead. Maybe not in our lifetime, but your grandchildren's lifetime. Maybe things really transform. Like I say, the flying hoverboard, right? People make it come true. You saw that in the Batman movie, right? The bad guys on the flying board. Now we have it for real, right? So that's why I say, John Shoki was saying, flying cars are definitely coming. So what else is not coming? So questions? Anyone?
Question?
Yes, sir.
Claudia?
My own question is kind of simple, but I'm not sure the answer will be that simple. So it looks to me that there's a lot of agreement about the fact that we as customers, we are willing to give us our data to have some service back, more security, safety, those kind of things. But it also looks to me that this also means that maybe we are going to have There are very few companies, maybe just one company, not a government, those companies that will be able to provide the better algorithms in charge of running everything, even politics. Is this vision shared by you as well, or you see that there will be some sort of way to control that this will not happen?
Yeah, I think that's a very good question. Data and privacy, security, I think it's always interlocked. It's always a compromise. If you have very few data, you may end up not being very intelligent. If you have a lot of data, you may be more intelligent, but sometimes you can become stupid. Because the way we do AI right now, okay, pardon me, I'm not quite an AI guy, but I did study artificial intelligence. I think we're trying to create a machine that tries to think and reason and learn. Right? So we need data. Without feeding data and learn, create a model to create and generate an outcome, there's no intelligence. Right? So to put it simply, we have not generated or copied human intelligence. We are not able to even understand human intelligence, right? Even able to preserve that. So think about the intelligence of Einstein. How can we preserve Einstein intelligence for use today and tomorrow? No one has done. So our AI now is so data dependent, right? So if you don't have enough data, your model is totally messed up, totally not accurate. So what good is the model? And how many models is enough to run the system? 10,000, 100,000 models of everything? So I think to make good sense, we need a certain amount of data to enable the current state of AI that we are in, right? To generate good predicted output. So we need to create that balance, right? So based on the current AI capability that we have created, we need a certain end-to-end amount of data. So we must be willing to give in, to provide this end-to-end data so that this current state of the AI will work well, right? That will drive the application that will benefit us.